Okay, so what we're going to look at here is converting to hexadecimal. So we're going to go from binary to hexadecimal. Now, there's a few things you need to know first. So if you think when we're working in normal numbers and you have, we'll say 19 plus 11, when you go 9 plus 1, that becomes 10. So in this units column, we've got to put a 0 and carry the 1, and then that would give us 30. Okay, so what we have to do is 9. There was nothing greater than 9 that we can use in decimal and denary numbers. So we had to then go into the tens column, not the units column anymore. Now, when we're adding in binary, it's very similar. So in binary, if you've got a 1 and you're trying to add another 1 in binary, 1 plus 1 is actually going to be equal to 1, 0. And then if you try to add another 1 to it, 1, 1. And then again in binary, if you add another 1 to it, 1 plus 1 gives us 1, 0. 1 plus 1 gives us... Okay, so that's the first thing you need to know. Right, the next thing you need to know is hexadecimal is base 16. So if this means we've got 16 symbols that represent the numbers that we need. So 1, 0, 1. Now we get to 9, which has actually given us 10 different symbols. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then what we're going to do is we're going to go, right, we're going to use A, B, C, D, E, and F. So we know we've got up to 10, 11, 12, 13, 14, 15, 16. So this is our base 16. Now, what we're then going to do is we are going to convert each of these hexadecimal symbols. So this is our hex, and then we're going to put that into denary. So what we do here is we're going to use something called a nibble. So a nibble is half of a byte, and a byte was 8 ones and zeros. So we're going to go 1, 2, 3, 4. We're going to add a 1. We're going to add another 1 to that, which would actually give us 1, 0. That's a 1. Then what we're going to do is we get up to number 8 here, which is going to give us 1, 0, 0, 0. So I literally keep going, just adding 1 each time. And that'll give us 1, 0, 1, 0, 1, 1, 1, 1. One, 1, 0, 1, 1, 1, 1. Okay, so what we've got here are our hexadecimal symbols, and then we've got the denary representation. Now, what we're going to look at next is how we actually use this table then to convert a byte of data. So if we have a byte of data, so we're going to say we're going to say 1, 1, 1, 1, 0, 0. So what we do is we split this into 2 parts. So we've got part 1 and part 2. So that's nibble 1, nibble 2. 1, 0, 0, 1. We look down here. We have got 1, 0, 0, 1, and that is a 9. And then we have a 1, 1, 0, 0. We look down. 1, 1, 0, 0. So the hexadecimal for this is 9C. That's the conversion. So this time if we had this one, again we split it into 2 nibbles. We've got an F for this. 3 zeros and a 1. 3 zeros and a 1. So that is going to be F1. That's the conversion.